Natural gas will be the world's fastest growing major energy source through the year 2040. This energy source carries tremendous benefits for consumers and the environment. It is versatile, clean burning, and abundant. Natural gas resources can be located in remote areas, and these resources are produced from subsurface reservoirs, both onshore and offshore. A complex value chain transports natural gas to consumers around the world. The value chain begins with the process of bringing natural gas to market by safely drilling wells to bring the gas and other reservoir components to the surface, where it may be processed on-site or transported to a facility for treating and processing. Natural gas extracted from subsurface reservoirs can contain non-hydrocarbons, including hydrogen sulfide, nitrogen.
As reservoirs deplete and sand control challenges increase, Weatherford provides the organizational capabilities, expandable completion understanding, system reliability, and installation experience to address your sand control challenges. Weatherford's expandable reservoir completion system combines the best of both worlds: open hole productivity with cased hole functionality for enhanced reservoir management. Maintaining hole quality and minimizing formation damage are pivotal to the productivity of any open hole completion. Using standard drilling techniques can achieve good hole geometries within the compliant expansion range of the screen. Drilling fluid changeout is not required. This results in significant health and safety and runtime efficiency.
As the gas cools, it is reduced to 1/600th of its previous volume. The resulting liquefied natural gas is clear, colorless, and ready for transport. The liquefied natural gas, or LNG, is stored in large insulated tanks until it is ready for shipment. Pipes connect the storage tank to a loading jetty. Regardless of outside temperatures, the LNG inside the tanks and loading facility remains at -260 degrees Fahrenheit or -162 degrees Celsius. The LNG is then pumped into specially designed LNG ships. LNG shipping tankers transfer natural gas around the world. Some of the largest LNG ships, such as the Q-Max, are longer than 60 city buses. And each Q-Max LNG nitrogen, carbon dioxide, and water. The treatment processes remove these components from the natural gas. A solvent is used to absorb carbon dioxide, hydrogen sulfide, and water. Heavier liquids are removed from the lighter gas for separate processing. Water is removed, and the remaining natural gas is ready to be cooled into a liquid. Depending on the source of the natural gas, it may need to be transported to a liquefaction facility. The gas is transported by pipeline and can travel hundreds of miles or just a few feet to a liquefaction facility. This depends on where the gas treatment facilities are located relative to the liquefaction plant. The liquefaction plant cools the gas to -260 degrees Fahrenheit or -162 degrees Celsius.
Horizontal steam injection to safely and cost-effectively increase recovery from new and existing reservoirs. First, we drill wells down hundreds of feet before turning the bit horizontally to drill out thousands of feet in the targeted production zone. Once the well is complete, an injection well pumps steam into the reservoir. As the injected steam makes contact with oil, heat is transferred to the cold heavy oil, reducing its viscosity and making it flow more easily to the producer well. This approach efficiently recovers more resources with a smaller environmental footprint than drilling multiple vertical injection wells. It also enables Chevron to develop thin reservoirs, lower costs by eliminating the need for multiple vertical wells, and increases oil response with higher.
Refineries convert crude oil and other liquids into petroleum products that people use every day. Products such as liquid petroleum gas, or LPGs, gasoline, diesel, jet fuel, asphalt, and lubricants, just to name a few. These products are produced by distilling crude oil and cracking or reforming the recovered fractions. Refinery complexity varies substantially between different refineries based on total capacity as well as the types of processing units. Crude oil is delivered to the refinery through various forms of transportation, such as pipelines, ships, trains, and even trucks, and is stored in large tanks at ambient temperatures, typically around 70 degrees Fahrenheit. From the storage tanks, crude oil is sent to a furnace for heating, where the temperature can range between 650 and 670 degrees Fahrenheit. The heated crude is then sent to a distillation tower, where the pressure inside the tower is typically in the range of atmospheric pressure. Once the crude oil begins to heat and vaporize, this mixture of hydrocarbons will travel up the distillation tower. And as the vapor travels up, it is cooled to the